students, welcome to Stuti Academy. In this video, I'll explain structure of the atom chapter to you. As we all know, in this universe, everything is made up of matter. And this matter is also made up of certain substances, which we call them atoms. John Dalton said that atoms are the smallest particle, but it is not actually true, because these atoms are also made up of subatomic particles. And these subatomic particles are electrons, protons, and neutrons. So in this chapter, we'll study about these subatomic particles, their discovery, what kind of charges are present on them, and how they are located in an atom. Although many scientists gave their contribution in the field of electric charges. For instance, William Gilbert, he said, when we rub silk cloth and glass rod together, then some weak charges are produced. On the other hand, Faraday said that flow of current is also due to some charges. G.J. Stoney, he was the first one who gave the name electron. And J.J. Thomson, he discovered the existence of electrons in an atom. E. Goldstein discovered protons. J. Chadwick discovered neutrons. How they discovered these subatomic particles, we'll study in detail. The cathode rays, which are present in the discharge tube, it travels in a straight line, and they are independent of the gases present in the discharge tube. So this is about the discovery of what type of question come in the exam on the basis of this topic. This is first question is who discovered electron? It's a 1 mark question, and the answer is J.J. Thomson. Next question can come like this: describe experiment performed by J.J. Thomson to discover electron. So in this question, you need to draw the diagram and you have to explain the entire experiment which I have just explained to you. Next subatomic particle is proton. Proton was discovered by E. Goldstein. In his experiment, he also opted for a discharge tube, and in this discharge tube, he also took 2 electrodes. One is cathode and one is anode. But in his experiment, this cathode is perforated, which means it has some canals or pores in it. When he passed electricity at a very low pressure and high voltage, the canal rays, or we call anode rays, produce from anode towards the cathode, and they pass it through these canals or the pores in the cathode, and they strike at the other end, which results in the red glow. And some positively charged particles were observed in the discharge tube, and these positively charged particles are the protons. So this is how protons were discovered. The anode rays which were produced during this experiment are also known as canal rays, because they passes through the canal of the cathode rays. So this proton was discovered by E. Goldstein, and it is represented by this symbol, and charge present on proton is plus 1.6 into 10 raised to power minus 19 coulomb, which is exactly similar to that of the electron, only the difference is of charge. Electron has negative charge and proton has positive charge. And mass of the proton is 1.67 10 raised to power minus 24 gram. In some books, this number varies. In some it is written 27 or 28. So all are correct one. So in this manner, the protons were discovered by E. Goldstein. Now, what type of questions can come from this topic? Again, who discovered proton? It's a 1 mark question and the answer is E. Goldstein. Or sometime they ask, describe experiment performed by E. Goldstein to discover proton. It is 2 mark question. So in this, you have to explain the entire experiment along with the diagram. And it's 1 mark question again. Why anode rays are also called canal rays? It is very important question. Anode rays are also called canal rays because they pass through the holes or canals of the cathode. Next subatomic particle is neutrons. Neutrons were discovered by J. Chadwick. And they are represented by symbol small n. He took beryllium sheet for his experiment. Then he bombarded some alpha particles through it. And then he observed some particles were emerging which were carrying no charge, and they were neutrons. It means neutrons doesn't carry any charge. No charge is present on the neutrons, but the mass of neutron is similar to that of the proton. They both have the same mass. This is how neutrons were discovered. And generally this question asked from this topic, who discovered neutrons? And the answer is J. Chadwick. Now this is the comparison between the 3 subatomic particles. If we look at this table, electrons, it has 1.6 into 10 raised to power minus 19 coulomb. Just remember negative sign. Don't forget to write the negative sign. Mass of the particle is 9.11 into 10 raised to power minus 31. As I told you, in some books it is written minus 28, minus 27. So all are correct one. And it is represented by this symbol. And it is located outside the nucleus in an atom. Then proton. Charge on the proton is similar to that of electron. Only difference is of discharge. It is negative and it is positive. Mass is 1.67 into 10 raised to power minus 27. And symbol is this. It is present inside the nucleus. Now neutron does not carry any charge. Its mass is also similar to that of proton. In somewhat cases, it is more heavier than proton. But more or less they are same. If we do comparison, a little bit of difference in their masses is there. Otherwise, they both are of the same type. Now symbol is this, and it is also present inside the nucleus. Now what type of questions can come from this topic? Question number 1 is, if an atom contains 1 electron and 1 proton, will it carry any charge or not? As I told you, in an atom, electrons are present outside the nucleus. And inside it, protons and neutrons are present. So if an electrons and protons, if carrying the same charge, electron carrying charge 1, proton also carrying charge 1. So it is minus 1 and plus 1. Answer is 0. So that particular atom is electrically neutral because they neutralize the effect of each other. Next is, name the 3 subatomic particles in an atom. These are protons, electrons and neutrons. Third is, if an atom has 1 proton and 1 electron. Again, similar type of question as question number 1. State the charge on the atom, justify your answer. Again, the atom is neutral because 1 proton and 1 electron is present. They both nullify the effect of each other. Minus 1 plus 1. Okay. 0. The atom is neutral. Now we'll study about structure of atom. There are different scientists who gave their theory and models regarding the structure of atom. And first model is J.J. Thomson model. It is also known as plum pudding model. Like in a pudding, some raisins are scattered. or we can compare it with a watermelon. Like black seeds are scattered in the watermelon. So J.J. Thomson, he compared the structure of an atom with the plum pudding. He said electrons are present in the positive sphere of an atom, and these electrons are negatively charged and they are just embedded inside it. But he was failed to give the stability of the atom and about the location of electrons, exactly where they are located, and he was failed to give the location of the other subatomic particles also. Now, what type of question can come in exam on the basis of J.J. Thomson model? That is, on the basis of Thomson model of an atom, explain how the atom is neutral as a whole. As Thomson said, atom is a positive sphere in which electrons are embedded. It means atom is a positive sphere, the entire sphere is positive and the electrons are embedded, which are negative. So positive and negative, they both are come together and make the atom neutral. They balance each other in an atom. Now, what are the limitations of J.J. Thomson model of an atom? First limitation is he could not explain the result of this scattering experiment. Scattering experiment means like the electrons were present in it, but how they are present, where they are located, what happens if they are moving in an atom, the entire things were not explained by the J.J. Thomson. And he did not give any experimental evidence about his model. Next model came into existence was Rutherford. In his model, Rutherford took a radium in which he bombarded alpha particles which were positively charged, and he selected gold foil for his experiment because gold foil can be converted into thin sheet, and being a heavy metal, if alpha particles bombarded on it, they can easily scatter from this gold foil. And he took zinc sulfide screen. Now, what happens in his experiment when he bombarded alpha particles on the gold foil? He observed that some of the alpha particles passed through the gold foil, some were deflected to small angle, some were deflected to large angle, and some were rebound. So these were the observations taken by Rutherford when he performed his experiment. These are the alpha particles when they pass through the gold foil. This is the gold foil. As you can see here, some move straight, some shows deflection to a small angle, some are deflected to a large angle, and some are bounced back. These were the observations of the Rutherford experiment. And when he observed these things in his experiment, he came to few conclusions. Those conclusions are: most of the space inside the atom is empty. That is the reason why these alpha particles pass through the gold foil. He said, if there is space, then only the alpha particles were able to pass through it. It means lots of spaces were there. That is the reason why most of the particles were passed out. They moved straight. On the basis of his next observation, he said very few particles were deflected from their path because positive charge of the atom occupies a very little space. It means because alpha particles were also carrying positive charge, and it means same charge is present somewhere in the atom, but it is present in a very small space. That is why only small particles were deflected. Because positive, when they attract, when they strike with each other, they shows a repulsion, and that is why the deflection took place. The next conclusion was very small fraction of alpha particles, this is alpha particles, they were rebound. It means in an atom, in a very small area, the mass of the atom is present. That is the reason after striking to a very heavy substance, they rebound. But only few fractions of alpha particles were rebound. It means that mass is quite very present in a very small space. Then the radius of the nucleus calculated was 105 times less than the radius of the atom. He said the radius of the nucleus which is present in an atom, it is 105 times less than that of the atom. So these were the conclusions of the Rutherford scattering experiment. On the basis of his experiment, this picture came into existence. And in an atom, center contains positive charge, that is called nucleus. Rutherford discovered nucleus also, and all the mass of an atom contained in this nucleus only. And electrons are revolving around it. And size of the nucleus is very small as compared to the size of the atom. But again, there were some drawbacks or the limitations of the Rutherford. When he was saying that in an atom, center contains positive charge, that is the nucleus, and electrons are moving around it. And he was saying when they were moving around the nucleus, they were radiating energy. If they were radiating energy, it is but obvious that they start moving towards the nucleus. And if they start moving towards the nucleus, they merge into nucleus and the atom become unstable. But it is not true. Atom is stable in nature. So that's why his model was not at all, not completely accepted. And these questions comes in exam on the basis of Rutherford model. On the basis of Rutherford model of an atom, which subatomic particle is present in the nucleus of an atom? And the answer is protons. The next question is, what do you think would be the observation if the alpha particle, this is alpha particle scattering experiment is carried out using a foil of a metal other than gold? If a metal is a heavy metal like gold, then the silver, then like silver or platinum, so we'll get the same result. But if the metal was light, then it is very difficult for the alpha particles, because alpha particles are itself, they are very heavy, and if they bombard on the sheet of the lighter metal, then they push the nucleus aside and pass through it and causes some deviations. The next model is Bohr's model of an atom. Bohr explained the concept of the Rutherford in detail. He said electrons are moving around the nucleus, but they are moving in a particular orbit. He said nucleus is present in the center and electrons are rotating around it in a particular orbit, and we also call them shells. And when they are rotating or revolving, they are revolving around the nucleus, they are not radiating any energy. And these orbit or shells are called energy shells, which are represented by alphabets K, L, M, N, or by numbers 1, 2, 3, 4. So this is Bohr model. Nucleus is present in the center. Electrons are revolving around it in a particular orbit, but they are not radiating any energy. So this type of question can come. Draw a sketch of Bohr model of an atom with 3 shells or 4 shells. So this is the diagram you need to draw. or they'll ask about the postulates of Bohr model. Then in this, you need to write these postulates. Now these are three models: Thomson, Rutherford, and Bohr model. This is the summary of these three models. Thomson model: atom consists of positively charged sphere and electrons are embedded into it. Negative and positive charge are equal in magnitude, which makes the atom electrically neutral. Rutherford said positively charged is present in the center, and he gave name nucleus to it. And he said all the mass of an atom present in the nucleus. Then he said electrons revolve around the nucleus in a well-defined orbit. Then he said size of the nucleus is very small as compared to the size of the atom. Bohr model, he said there are certain special orbits known as energy shells in which electrons are revolving, and he said while revolving they are not radiating any energy. Now question can come in exam. Compare all the proposed models of an atom given in this chapter, or they'll give the name of the chapter also. So in this question you have to write this answer. Draw a table and then compare all the models. Then how these electrons are distributed in these orbits or the shells. And the formula for this is 2n square. Here n is the number of shells. If n is equal to 1, means we are talking about k shell. So according to formula, 2 electrons can accommodate into k shell. We have k, l, and k. And if n is equal to 2, it means we are talking about l shell. According to the formula, 8 electrons can accommodate into. If n is equal to 3, means it is m shell, and 3 electrons can accommodate, 18 electrons can accommodate into it. And then if n is equal to 4, it is n shell. According to the formula, just write down in place of n, just write down the number of shell 1, 2, 3, 4, and then 32 electrons can. And we can only fill the shells in one condition if the previous shell is completely filled. Suppose it 2, 8, 18, 32. First we need to fill the previous shell. Then only we will fill the electrons in the next shell. And an element to be exist in nature, an atom exists or becomes stable in nature only if its outermost shell has 2 or 8 electrons, and its 2 electron should be, it has k shell. Two conditions are there. Either its outermost shell is k, which has 2 electrons, or it has 8 electrons in its outermost shell. For example, aluminium, its atomic number is 13. I'll write down the electronic configuration of aluminium. This is 2. Then we can write 8 because it has a tendency to come only 2 electrons can fill into k shell. Then 8. 8 and 2 is 10. Then its atomic number is 13. So we need 3 more electrons. We can accommodate. But its outermost shell is M. It has 3 electrons. So it is unstable in nature. And how it can become a stable in nature? Either it gives 3 electrons, then its outermost shell, L becomes outermost shell, which has 8 electrons. Or it can take 5 electrons. So 3 plus 5 becomes 8. But we always choose less number of electrons because it needs tremendous amount of energy. So it is easy to lose 3 electrons in place of gaining 5 electrons. So its valency is, and if an atom, an element loses electrons, it becomes positive, and if it gains, it becomes negative. Then, yes. Now, what type of question can come? First is, the atom of an element A has 3 electrons in the outermost shell. Means, in its outermost shell, 3 electrons are present, and it loses one of these. A has 3 electrons in its outermost shell, and if it loses one and give to the other element B, what will be the nature and value of charge on ion which results from A? It is giving electron. If it is giving, becomes positive, and it is giving one electron, so it is A positive. You can write. Question number 2. The atom of an element has electronic configuration 286. Does it gain 2 electrons or lose 6 electrons to have the configuration of the nearest noble gas element? Noble gases are those which have completely filled octet. Outermost shell is completely filled. It means it has 8 electrons in its outermost shell, and these gases are known as noble gases. And if an element has 286, its electronic configuration, it means its atomic number is 16. So it will, does it gain 2 electrons or lose 6 electrons? There are two conditions to become stable. Either it lose 6 electrons or gain 2 electrons to become 8. As I told you, we always opted for the less number of electrons. So it gained 2 electrons and it attained the electronic configuration of noble gas, which is argon. Now its atomic number is 18. Now comes valency. As I told you, if an element loses electron or gaining electron, that combining capacity is known as its valency. I'll take few examples like chlorine. Its atomic number is 17. I'll write its electronic configuration. In K, we can write only 2. And in L, first we'll write 8 electrons, and 8 and 2 is 10. 7 are left. I'll write 7 here. And here, to become stable, either it will lose 7 or take 1. We always opt for the less number of electrons. So we take 1 electron. So it is gaining 1 electron. And if it is gaining, charge is negative on it. And we can write like this, because only 1 electron is gained by chlorine. So this is known as valency, the losing or gaining of an electron to make its outermost shell completely filled. Atomic number is equal to the number of protons and number of electrons. Mass number is, it is equal to the sum of protons and neutrons. Now in this table, elements are written with their symbols and how many number of electrons are present. It means it is their atomic number also. Electrons are equal to protons and atomic number. They all are same. This is first shell, We can write K, L, M, N, and this is their electronic configuration. How can we write this electronic configuration? Like, for example, magnesium, number of electron is 12, 2A2. This is okay. And what type of questions can come from this topic? Like, write the distribution of electrons in carbon and sodium atom. Means you have to write the electronic configuration of carbon and sodium. But before that, you need to learn atomic numbers. These are 1 to 20 atomic numbers. You can learn these atomic numbers. Carbon atomic number is 6, which is represented by symbol Z also. And its electronic configuration is 2. And sodium, carbon can gain or lose 4 electrons. Both are same. And this property is known as catenation. When carbon combines with other carbon to make its octet complete, this tendency is known as catenation. Then we have sodium. Atomic number is 11. K, L, M, N. In K, only 2 can come. First, we will fill L with 8 number of electrons and only 1 is left. This is the electronic configuration of sodium. If the K and L shells of an atom are full, means K and L shells are completely full. In K, only 2 electrons can come. In L, only 8 electrons can come. So what would be the number of electrons in the atom? It means 2 plus 8 is equal to 10. It's 10 number of electrons are present in the atom. Mass number is represented by symbol A and atomic number is represented by Z. And when we write an element, the number which is written above, it represents its mass number, and the number which is written here, it represents its atomic number. This is mass number. Mass number is equal to number of protons plus number of neutrons. When we add number of protons and neutrons, we get its mass number, and number of protons is equal to number of electrons and atomic number. Electrons. If we need to find out number of protons, formula is mass number minus atomic. These type of question can come in the exam. First is find the element mass number whose atomic number is 18 and the neutron number is 20. It means number of proton is given, atomic number 18. Atomic number is equal to number of protons is equal to number of electrons. If atomic number is given, it means number of proton is also 18, number of electron is 20, and atomic mass number we need to find out number of protons plus number of neutrons. We just add both the numbers. Mass. Then question number 2. Helium atom has atomic mass of 4 mu. This is the unit of atomic mass. And has 2 protons in its nucleus. How many neutrons does it have? Mass number is equal to the atomic mass. They both do not have any units. Mass number is 4. The number of protons in the nucleus we need to find out is equal to atomic number, because protons and atomic number, they both are same. So we need to find out the number of neutrons. A minus Z is the formula. 4 minus 2. As I told you, number of protons, mass number minus atomic number. Same thing we are doing here. Mass number minus atomic. The answer is 2. There are certain substances, we call them isotopes. Isotopes. Isotopes are those substances whose chemical properties are same but physical properties are different. It means they have same atomic number and different atomic mass. As you can see here, their atomic number are same. These are the isotopes of carbon. And different isotopes of an element can be used in different ways. So isotopes are those substances which have same atomic number but different atomic mass. Easy way to learn is Sandam. Same atomic number, different atomic mass. And their masses are different. The isotope of uranium is used as a fuel. Isotope of cobalt is used in the treatment of cancer. Isotope of iodine is used in the treatment of goiter. And these isotopes have same chemical properties, but their physical properties are different. Next is isobars. Isobars are just opposite to that of isotopes. They have same atomic masses, but different atomic masses. Same atomic masses, different atomic numbers. Samdhan. Easy way to learn isobar. And what type of question can be asked in exam? Do isobars have also identical chemical characteristics like isotopes? And the answer is no, because the isobars have different atomic numbers as well as different electronic configurations. So their chemical properties are not identical. But in isotopes, they are identical because their atomic number are same. Question number 2. Which radioisotope is used for the treatment of cancer? And the answer is cobalt 16. Out of C12 and C14, they both are isotopes of carbon, which is of radioactive nature. Answer is carbon 14 is radioactive in nature. I hope you like the session. Thank you.